this project in 15 minutes tonight. Not going to happen. Just reading that problem took me longer than I think somebody put into it for me to read it. Okay, so I want to go through some of the project details and make those expectations clear and get the math straightened out. The first was this template. I thought that template confused you. And the template is just what they expect, the leadership expects for writing. I actually expect a little bit more because I thought that that writing that was in that template was sparse. You were confused by it. If you were confused by it, then you should not write less than what's written there. You should probably write more. And you can make things your own. So they have this thing called parameters. And a lot of you looked at that one. I don't know what that is. It looks like it's a leftover from the previous MA 103 that we used to teach. We had something called parameters that we talked about a lot. What parameters are they are actually those numbers in your constraints and in your objective functions that are specific to this problem. You change the parameters, the whole problem changes. But that's why we have them in the cells in Excel so that you can actually change those numbers. And like once you set up an Excel spreadsheet, you can really just modify that for anything else. An example of a parameter is, I've developed weight loss models, and they're dependent on age, height, initial weight, and gender, and a number of other things. So when I input in those parameters for you, they're going to be different than inputting them for you. So those are parameters. I have like a spreadsheet, and I'll put in the different, somebody else comes to me, they'll put in their parameters, and I could re-simulate that model. That's what's meant by parameters. I think what was really meant is constraints, not parameters. And some of you kind of read that and thought, I think this has something to do with my constraint. So I X'd off in some of yours that this should probably be constraints, not parameters. That's okay. You put constraints. You were also confused by, by the way, I'm going to show you like a template that I made with some additional guidance on it. But on the cover sheet, like right under the cover sheet, you're going to have to address all the feedback. I tried to write as much as possible on all of your projects, either inside the project as I was reading it or on this rubric that I gave you. All of that has to be turned in your final project. And you have to address those comments. And I'm going to show you an example of how to do that. But that's probably the most important thing. You learn from falling and then getting up and then learning from that. So for me, that's really important. I'm going to tell you that that's 10 points on your project, just addressing your feedback. And that's going to be pretty binary for me. So you're going to get feedback from your peers as well. So address the feedback, 10 points. Don't address some of it. I'm actually tending towards a 0. Address all that feedback. Make sure you have all that done. So some of it is up here. I kind of directed the last ones I graded as, hey, let's look at up here and make sure that this general feedback is also in there. So the second thing I thought you were confused by are what are assumptions. There's 2 types of assumptions. One is for model building and one is for model solving, if you want to make 2 buckets. For model building, I have to take that they're given was actually correct. So that's just, I'm going to assume whatever they're telling me is correct. That's not always true in real life. Sometimes people tell you things. I ate all my meal. Did you really? Did you drink the milk out of the cereal bowl? Like, I can't take that for an assumption that's given. So there's uncertainty usually, and you're going to come across that. We're going to actually cover that in here. But those assumptions right now are your givens, that they're actually ground truth, that they're correct. So we're going to talk later about robust solutions and variation. So we're going to address this because in reality, that's not always correct, right? But for now, you're assuming whatever they're giving you in the word problem is correct. They say there's 10 being shipped here or there's low risk here. That's all correct. The second type of assumption is assumptions defined using simplex. And there's two assumptions behind using the simplex method in solver. We need solver to solve this, right? So it's one assumption is that objective functions and the constraints are what we call linear. I'm going to show you that. Wait till the drama unfolds. I'm just giving you the feedback first. All right, so assume that the objective functions and constraints are linear. They call that proportionality in your book. That's the proportionality assumption. That means that everything's directly proportional to everything else. That you can just take a percentage of whatever the decision variable is, and that you have no squares, and then you have no rational functions. You don't have anything weird looking. So that assumption is not always correct, but this is usually a good approximation, even if this is not correct. So for example, I don't know what you do. Do you feel comfortable disclosing your weight? 180. 180. What's your weight? 155. So if I didn't tell you anything about these two, and I told you there's someone in my office, 150 pounds, you have an image in your head. But then I tell you he's 6 feet tall. Then you have a different image in your head. So somehow you have to normalize weight by height, right? So you would say, well, maybe I can just take everybody's weight and divide by height. I'm making an assumption that weight is directly proportional to height when I do that. We have found in studies that's not actually true. Weight is actually directly proportional to height squared. That would not be linear because there's a height squared in it. That's where BMI comes from. Weight divided by height squared. That's why we divide by height squared. And we have seen this over and over and over in the data. So that's an example where that's not directly proportional. Weight is actually directly proportional to height squared and not height. To be linear, it has to be directly proportional to height. So in all of your equations, they relatively look simple. They have just objective function is a1 times x1 plus a2 times x2 plus a. There's no x1 squared. There's no x1 divided by y1. So nothing weird like that. So that has to be satisfied. The second thing that has to be satisfied is continuity. And objective functions. And constraints. And I looked at your book. Your book says something like fractional answers are allowed, something like that. It's more than that. Pi can be an answer. That assumption is that your decision variables can be slid across the real numbers or whatever your constraint is. That's not actually true in the example that you have in your project. It never really, they didn't say it, but it didn't seem reasonable reading that. I don't think that's reasonable, actually, that you could take half a can of water. It didn't say that you could do that. It turns out the answer was all integers, but it's made up. In reality, you probably won't get integers. Someone had said, well, it's okay because if you get like half a can, I can just round up. That's actually not true. The fact that you have these continuous answers don't actually approximate an integer answer. Integer programming is devilishly hard. There's a guy in our department who's a number theorist. You change everything to integers, they're wicked hard problems. They're called Diophantine equations. And they're like way, they're so hard, like you guys think I'm smart, I'm not smart enough to actually attack those problems. They're open. A lot of them are open. That means they're not solved. And so going from continuous to discrete is not trivial. I guess we're going to address that sometime. But right now, you're allowed to assume it that they can take a fraction of a water can, which is probably not reasonable. I would actually write that. It's assumed for the solution method that you can have half a can of water, but it's probably not justified. I'm
Could that
just
be-
doing this to see what happens.
Could that be reasonable?
I don't think it's reasonable. I don't think it's reasonable. From the reading of it, it didn't seem like they could take half a can of water.
Like, I said that, like, in mine, for my assumption, I said they would more than likely take full cans of water, because if they took half cans, then that just put them more unnecessary risk, and it's like a misuse of resources.
Yeah, but were they like just assuming that if they had another empty can, they didn't say anything about empty cans, so that's not in my given. Like, where are they going to pour that water for? It just seems really like an unreasonable assumption that they could take pi divided by e cans of water, right? So, but I'm just seeing what happens. Like Colonel Watts says in the dean's office, you can do whatever you want. You can apply the algorithm and see what happens. Doesn't mean that this assumption is reasonable to me. Okay, so those are your assumptions that I think is wanted in the project, is these two, that everything's linear and that everything is continuous. The good student would have all of this. The great student would say, hey, I looked at this. I don't really think that's quite right. Right? That means that you're ready to apply this somewhere else. You're really thinking about it. Let's see. Ask me questions if you have questions along the line.
What were we supposed to do for distribution plans?
I'll get into that. I'm going to show you all that stuff in a second, where everything goes. All right. Anything so far that I've covered? Okay, next thing is the penalties. The risk penalties. Anywhere you have in your prompt, if you read the project prompt, I read it many times because doing AI, I have to be teed up before I come to you. Did anywhere in the prompt, did they tell you that the risk penalty for low risk is 1? Anywhere. They did not say that ever. That's not a given. Some of you had that on the given. It's not a given. And I pulled the cadet daily method. I just said, let's make that another variable because they didn't say it. But I have to have, everything has to be quantified. Otherwise, there's, you don't need me. You're like working out there subjectively with some fuzzy idea like that. I need numbers to go through something. So I said something like P1 is the low risk quantified value. They didn't give it, but I just said P1 is that. You guys have, all of you, I think, unless I feel like there might have been one cadet that had this in there, something about this, but everybody missed this. You have to have this because it's like a key piece. They didn't give me a number, so I'm just going to call it P1. But they did tell me relationships between the medium risk and the high risk. They said that P2, which is the medium risk, quantified. I don't know how they're quantifying it. That's equal to 2 times P1. They gave me that. And they also told me that P3, which is the high risk, quantified. By the way, this is per can of water. They say that. Per can of water. And this is called the per can of water. They gave me this. That's 3P1. So my total risk is going to be all the ways that I have low risk on that chart. I'm not looking at that chart in front of me, but some of you actually printed it into your project, that figure. I first look at all the ways I can take. How many cans of water am I taking from A11 to platoon 1?
2. Oh, about 7 water cans.
No, like how many? Like what were the decision variables? Some of you didn't have the decision variables correct.
It's a 2. It's a medium risk.
What were your decision variables? I used X1, but I don't like lots and lots of subscripts.
Water is moving from.
What? That's not quantity. Has to be quantity.
Number of water cans AA1.
Oh,
And then X2 would be, I think Kate said that the rest are easy once you get the first one. So like X2 would be the number of cans that you move from AA1 to platoon 2. AA1 to platoon 2, and then X3 would be the ones that you move. So here I would need the total low risk, because this is total risk. And here I would need total medium risk. And here I would need total high risk. Let me draw that thing up here if I can. It's not going to be in the video. Maybe I'll put it up here. Don't fall asleep on me. I don't like to talk this long, but I know I'm boring after a while. So stay with me. Cooper, did you have the picture in your work?
I had this like table thing.
Okay. I need the picture.
Oh no, I didn't have the picture.
Some of you had the picture like this thing. Yeah. Can you tell me what to draw?
Yeah, so it's
There's 3 platoons. So let me do platoon 1, platoon 2, and platoon 3.
so you have the first line is AA1, platoon 1, and that's a medium risk.
Okay, this is medium.
Yeah. And that second line is the low risk platoon 2,
Okay.
and then a medium risk platoon 3.
Okay. And then we had 3 lines going this way too, right?
Top is high, medium, high. So high top, and medium in the middle.
I've lost my track. And then high. So now, if X1's the number of cans moved from AA1 to platoon 1, then X2 would be the number of cans moved from, I don't have space to write them all on this board. I can write them over on that board so that you see them. X2 would be number of cans moved from AA1 to platoon 2, and X3 would be number of cans moved from AA1 to platoon 3, Y1, Y2, Y3. The number of cans moved from A. Okay, right, you get these for free. So platoon 1. You don't have this correct. If it were up to me, I would give you a 0 because you missed the whole point of the problem. There should be no such a thing as partial credit. If I really want you to learn how to do the problem and you messed up this part, it means that you didn't understand anything in the problem. So the rest of it's all baloney. So that's the most important thing, is to get this right. Have them as quantities. It's not platoon 1. That's a noun without a quantity on it. It's the number of water cans that go there. There was also confusion with risk. Some people put risk into the decision variables. I don't know how to, I understand where that would come from because there's so many words. I had to really think about it, read it and think about it to slice it apart. Like, what is it that I'm controlling? I'm not controlling risk. Risk is already set. I'm controlling the number of cans I can throw at different places. Cooper?
This part of distribution plans.
No, we're not there yet.
So
This is just the pre-work. This is where all the hours of work go into. It's just like getting the pre-work all set up.
just define variables.
Define variables and set up models.
Or
Yeah.
develop models.
Yeah.
So what I've gotten So you said like missing critical information.
It's here. I'm doing it here.
Is this the part where I messed up on? 'Cause this is like the only thing I see.
I can't do the individual from here because I'd have to look at what I wrote and sit with you.
Oh, it just says number of. That's all it says.
Yeah, you're missing the number of there. The
So
quantity.
I would have full points if I just put the hashtag.
Yeah, you can't think of this as point by point. If I was actually teaching you, I wouldn't give you points. I'd make you do this in a notebook, give you feedback, and give you full points for correcting it each time until you got better. So you can't think of this as like the old school problems, like I completed the square and I got this step wrong. You really have to think about it as the whole thing itself. All of this is the most important step, is getting this right. Because you don't know what you're looking for if you don't have this part right. You're looking for a number of cans to give out. It's tied to your final answer.
So I didn't put that, but when I got later on, I have like the number of cans.
I don't want to know that you may know or may not know something. I need to know you got that part right. And it's not just me. Your projects are being graded by someone else. Get this part down. They're going to hack maybe more than I don't know. If it were up to me, I'd 100% make sure you got that step right. And I think I've communicated that to you in class. So I'm not grading your final projects. So everything I'm telling you is to tee you up so that someone goes, Cooper's is the solution key. We should use that as a solution key, right? I'm not trying to hurt you. I'll never try to hurt you. I'm here to help cadets. All right. So from that diagram, I do sometimes hurt the research cadets, but it's good for them.
So the whole total risk thing,
We're getting
that's in like the objective function.
Yes.
Okay.
We're not there yet. So we're now going to total up the total risk. What are the, in terms of the number of cans? So I have, if I look at the lows, I have AA1, that's X2, number of cans that go from AA1 to platoon 2. So that falls under the low risk. I also have, do I have any one that's another low risk? Did I leave off one of the low risks? Was this one low here?
Wait, so
Was this one a low?
That was the only low risk in the problem.
Okay, so it's going to be P1 times X2. That's my total low risk. What was this one? This one going down this way. This one was medium too. And then my total medium risk. Well, I just go look up there. It's X1, and I have medium. Yeah, how many? So I have an X1. Wait, yeah, X1 is a medium risk. Plus, what else? X3 is a medium risk. And, all right, I'm just going to trust you because I can't read my own writing. And then I know the total, like this is the total I'm taking out that have medium risk. Medium risk is going to be 2 times P1. So that's all my medium risk ones.
if you define it as P2 equals 2 times T1, can you just put P2 right there?
You can put P2, but I already have it in terms of P1, so this simplifies it. I'm using the information he gave me, right? And then the third one, give me all the ones that are high. Okay, I trust you. And then they said 3 P1. This is your objective function. Oh. And what do you feel like doing? Because you had so many years of algebra. Autopilot for no reason. What do you feel like doing? Simplifying it, but you got a P1 in everything, so simplifying it by factoring out the P1. Sometimes we don't even know why we're doing it. Is everyone clear what this is total risk and how it came about? Ask me questions because I want to make sure you understand everything before you go. This is the objective function. This is actually the objective function. And this is the critical part that was missing in everybody's work. That they didn't give you a quantity for P1. But if I factor out that P1, again, total risk, which I'm trying to minimize, that's equal to P1 times X2 plus 2 times X1 plus X3 plus Y2 plus 3 times Y1 plus Y3. And what I'm looking for is these variables that minimize this function. That I will do in Solver. This is beyond, you can't do it by hand. That I will do in Solver. But that P1 sitting out there, well, the thing is that if I have a minimum, whatever minimizes the P1 not being there is the same thing that minimizes P1 being there. P1 doesn't make a difference. Let's suppose I found the minimum of what's in the parentheses. What's in the parentheses, multiplying it by a P1, it's also going to be the same thing there. And the example I use, maybe it's a bad example. What if I have x squared? What's the minimum value x squared can take on?
X squared.
X squared. X squared.
1 or 0.
0, right? What if I put a 2 in front of it?
0.
It's still x equals 0. It still happens at the same location. What if I put 1,000,000 in front of it? It still happens at the same location. So the x variable that I have for this particular function happens at the same spot. The spot here is more complicated. It's x1s, x2s, x3s, and the y1s, y2s, and y3s. But if I just ignore P1 and find the minimum here, putting the P1 there is not going to make a difference. It's still going to happen at the same spot. So I need to say that somewhere. I can't spell.
And you want for the ones like we're doing solver, it says like 7 water cans or 10 water cans.
We're not there yet. This is all the methodology. We're still at methodology.
This is still like defined and identified.
We're still defining the functions, right? This is the actual objective function. This is the actual objective function. So when they say model, that's what you have. But for the solution, you don't know this. Everything has to be numbers that you put into Excel. And that's not a number. So you have to make the conclusion that I can just work with this because P1 makes no difference to the answer. So that's got to be in your written work, why you're using this, even though it's not the objective function. That's got to be there. Is that clear? That's just developing the model.
Where are we supposed to write the penalty? Does that go under variables? Or would that be parameters?
I would erase parameters and call it constraints. It would be under the objective function, right? This is how you develop the objective function. The objective function is total risk, and I need to compartmentalize the risk and say, here's the terms that are the total low risk. Here are the terms that are the total medium risk. And so that's where it goes, under the objective function. Is this clear? If you're shaky, ask me questions. Don't be afraid. No, it doesn't. If I have a set of, maybe it's easier to see this in a set of numbers. Let me show you in a set of numbers.
It would be okay if I expanded it.
You can expand it. You can do whatever you want. But yeah, actually, I'm pretty lazy, so I would actually just not expand it and just, because I have to type it into Excel. So it doesn't matter where everything is. I don't do any algebra unless I have to. But if you want to expand it, it makes you feel better, because sometimes I expand things because it makes me feel better, you should do it.
So I knew it was minimize cost. I went to the table and then I plugged in the risk factors first. I knew the risk factors going to be multiplying by which platoon didn't count.
I'll sequester some time. Hopefully we have time at the end of this so I can just work with you. I'm just working on the project today. because we actually did some work on, we're a little bit like, I feel in a better place. So I can talk to you about the project today.
I had like, when I did mine, I put like the medium risk as a separate penalty from the low risk, but if I like say the medium risk is twice that the low risk, in my case, you use my medium risk parameter as well. So I have like R sub L is my low risk.
Yeah, I think you were the closest to saying it. Kate and Paige did something where they said let the low risk be 1. They're making an assumption that they can quantify it that way. The reason why, when I saw them do that, I'm like, well, it actually works because it doesn't matter what P1 is. That's why. They just set P1 to be 1 because it doesn't matter. Let me show you why it doesn't matter. Tell me what the minimum of this set of numbers are. 1. Minimum happens here. Now I'm going to multiply all of these by 2. I don't trust my arithmetic. Where does the minimum happen here? Same spot. In fact, I could multiply all of these by a million. It's still going to be the first number that's the minimum, right? So the location of the minimum doesn't change. The x and the y are the location of your minimum.
So when I just let, like I use L be 1, should I put that?
You have to explain why you're allowed to do that,
Okay.
right?
And should I put that in my assumptions?
No, I think that's a conclusion. So that's a conclusion because of this, right? You can explain it using an example. For example, look at this. However you think it needs to be explained to not me. I'm not grading your project.
Okay.
So explain it to someone that hasn't seen you and doesn't know you, and they might care about you if they know you, but they really don't know you. So
Because I put the like let statements in my model, so under my model, should I put like conclusions and explain it in that section?
yeah, somewhere you have to explain, I can do this because it doesn't matter what this number L is,
Okay.
right? And here's why. I like that example, but you have to explain why you're just allowed to do that.
For me, like, do I have to organize it by low risk plus medium risk?
No.
Plus high risk?
No.
Like order I like X like platoon 1, platoon 2, platoon 3.
I don't care how you order it. Some of you ordered it different, but it has to be explained so someone that's not me can understand what you're doing. I want people from this group that's grading to come back and say, what'd you do with your cadets? They are absolutely phenomenal. Right? Knock it out of the park. Don't give them any excuse to cut points on you. So I'd rather like take off points here now and tell you like this is how you fix it than have someone else cut a whole bunch of points for you later that I don't know. I can't argue with them later because they would have graded everything the same way. Right? So to go back and say, my guy Neil's a good guy. He's a good cadet. He's funny. He can play the guitar. He meant this. They're going to say, so what? I've graded 1,000 of these the same way. So I don't want you to get into a bind there. But I'm not trying to hurt you. It's not what Dr. T wants. It's what needs to be there. Is this clear? If it's not clear and you're not comfortable telling me in front of the class, text me later and say, I didn't get you. I need some AI. I'll find the time for, you're not afraid?
Well, what's this part? Is this still the
We're still developing the model.
Delta model?
May I ask one question about how to format the spreadsheet?
No, like let's go to the end. So this is the objective function. Then we have the decision variables. We still have the constraints. And I have on your little table how to do that. And I've seen many do this on the board. So you're given these total amounts. You're given the 7, the 10, the 13. And what does this number 7 represent?
Water.
So this is the total water. I think of it in totals. It's the total water platoon 1 needs. That to me reads as a constraint. Like they absolutely need that. And this is the total water that platoon 2 needs. and this is the total water Platoon 3 needs, and they gave you two other numbers. What did they give you? I don't remember those two.
25.
25 and what?
10.
10. I don't remember what it is.
If they're water cans that each station holds, that they're able to give.
Each AA has.
Oh, so this is AA1s. Is this AA1s?
So they get 10 water cans.
And this is the AA2. So this to me reads as constraints because they can AA1 give out 11 cans? No, they can only give up to 10 cans. I can even tell you what the inequality looks like. It's going to be this. Right? Because this is a cap on what they need. These are equals. Cooper, pay attention to me. I want your attention. Not blaming you. I sit in meetings all the time and my attention drifts. Probably long before yours. Those are all equals because they absolutely need 7, they absolutely need 10, they absolutely need 13. If this is the total water that's needed by Platoon 1, over here I have to have expressions that total up water that's being carried to Platoon 1. So if that side's total water for Platoon 1, this side has to be total water for Platoon 1.
So greater than or equal to would be wrong for set of equals? So I had my.
Yes. Right. That was not clear 100% to me, but I read it as they absolutely need 7 cans. That means that's equal. They don't need less, they don't need more, they need that. So here this is going to be x1 plus x2, and I would do this like, because this is going to be put in solver, and in solver you're going to put the coefficients. So this is bookkeeping at this point. You don't want to make a mistake later. So put those zeros there. Good habits.
The X and Y are still the same to your left, right?
Yes, they're still the same.
What's the score?
0. There's 0 cans of water. Like this has stuff, but put them there because you have to put it in the spreadsheet. And then what's this one going to be? How many are going to Platoon 2? Well, I just go back here. X2 is going to Platoon 2, and Y2 is going to Platoon 2. So my total amount that's going to Platoon 2 is X2. Sorry, this is not right. Who is watching cartoons in here? That was not right. It's has to be one of this and one of this, right? And this is going to be one of this and one of this. And everything else goes somewhere else. And then that's my second equation. Now I'm writing very messy.
So we 10%, we're turning in everything fixed.
Yes.
And the executive summary.
I'm going to show you that. Hold off for a second. Show you how to frame it all. I'm just showing you the math now. I need to make sure that, like, there's no point in typing it if the math is all wrong. Make sure the math is all right. If you write them now, you will save yourself a grief later putting it into the spreadsheet, right? Because you need to put zeros for all the places that the coefficients are 0 in the spreadsheet, right? So this one was, what's the last one going to be? 1 here, so this is x3 plus 0y1 plus 0y2 plus y3. And that comes from the definition of these variables. That's how I know this is right. Did I do this upside down? Less than or equal to. Okay. Then I also have these two equations. What are they going to look like?
All the next one is x2 plus x3.
X1 plus x2 plus x3. I don't have x1. Like that. So
x1 plus x3 plus x3.
And then everything else will be 0.
So like we have 0, we write the rights for the like because I just have.
You have to explain how that got into the spreadsheet. So a lot of you had the spreadsheet with no explanation of what went in there. Like how do you know what to put? Did you know what to put in there? I had today AI. A lot of people didn't know what to put in there. So if you don't know what to put in there and you figured out what to put in there, you have to explain it to the reader. Here's how I'm putting this in here. These are my coefficients of these constraints on the left side. Explain it.
Is that distribution plan?
Not there yet.
Alright. So
This is not a 5-minute problem.
what if I like simplified all that down to like basic simple terms?
You need all of these as separate constraints to put into solver. So don't do any algebra to it. Okay. This is the format you're going to put into solver. And I did that the other day. That's already uploaded on YouTube. So I'm not going to do that right now. All right, is it clear where the constraints came from? If it's not clear, make a little note to yourself that it's not clear. I'm going to ask for this question offline. That's fine. But I need to make sure you understand everything before you go and type anything up. Okay, last part is the distribution plan. You're right. The distribution plan is just answering the question. The question is, how many cans do they need to take from different places so that it minimizes costs? That's our risk. That was the question. So how do you get that answer? You can't use the graphical method. It's beyond the scope of this class to do any of the algorithm behind, but there is something in Excel, a package that you can apply to actually solve this. And Jack actually figured out that that's actually a really, really cool thing that is possible to even solve this. The solver does all the work in the background. The simplest way you can solve this is just to guess and test. I'm going to guess and test and move numbers around until I land on the right answer. That's an algorithm. It's not a very efficient one, but it's an algorithm. But there's a more high-powered algorithm that does the rest of it for you. Once you get that answer, you have to communicate that to the person. Tell me what that answer was. I don't remember it right now.
7 total risk.
That's not what they want, though.
Well,
That's not what is wanted. They don't want to know the total risk. What do they want to know?
so when I use greater than or equal to, I still got 70, but I just got different numbers than 10 variables.
What is it they want to know, though? They asked you a question. What does that mean, though?
How do they distribute the load?
How did they distribute the water cans? So you got something, and I don't remember. There was a 7 in there.
7 water cans from A1.
X1 equals 7 water cans.
Platoon 2 needs 3 water cans from A1.
Yeah, so you have to have it as words. But can you give me the X1, X2, X3?
Okay, yeah. So X1, 7. X2, 3. Y2, 7. And then Y3, 13.
What about for the second problem, like when you change it to 4? You do that. When you change it to 4, like the high risk factor to 4.
It doesn't change anything. Or did they say to do that?
So change the total, like they said to make 2 optimal distribution plans. One where the high risk is 3, and one where the high risk is 4.
If that's later on, right? Then later on they give you this. This is the first part of the problem. Just solve it. Right.
Just the graph wise, it's not anything else. Just the graph.
There's no graph.
Excel.
Yes. So, and the rest are all 0. So the answer has to be put in words. What's the distribution plan? Because the person reading it doesn't have any idea of the math. Usually people you talk to are not going to know math. So you have to go back and say, I need to have 7, I go back to this. 7 water cans are going to be just taken from AA1 to platoon 1. 3 water cans are going to be taken from AA1 to platoon 2. 7 water cans are going to be taken from AA2 to platoon 2. And 13 cans are going to be taken from AA2 to platoon 3. That's the distribution plan. That is what they were looking for. That's the answer to the question. It's not the 70. I have to look at these other questions I haven't looked at that. Let me show you how to write it up now. All the math has to be done first.
Yeah,